If the existing 200 amp service is insufficient for an addition, there are ways to increase capacity. Firstly, consider upgrading the main service. This involves replacing the existing 200 amp service with a larger capacity one, such as a 400 amp or 600 amp service. This requires coordination with the utility company and a qualified electrical contractor. An alternative method is paralleling a separate breaker enclosure at the meter base to feed a second panel. This is often used to avoid the expense of upgrading the main service. To implement this, firstly, install a new meter base with a larger capacity, such as a 200 amp or 400 amp meter base. Secondly, install a separate breaker enclosure next to the existing meter base. Thirdly, connect the incoming power to both the existing and new breaker enclosures. Fourthly, install a new panel in the addition and connect it to the new breaker enclosure. Several important considerations must be taken into account. Ensure that the combined load of the existing and new panel does not exceed the capacity of the new meter base and breaker enclosures. The breakers in a parallel breaker enclosures must be rated for the same amperage and have the same trip characteristics. The existing and new panels must be interconnected to provide a single electrical system. This interconnection should be made through a main disconnect or interlock device. All electrical work must be inspected and approved by the local authorities. This method should only be performed by a qualified electrician who is familiar with the electrical code and safety regulations. A correct installation or paralleling can lead to electrical hazards, such as overloads and short circuits. A load calculation is crucial to determine the appropriate size for the new electrical service or parallel setup. Article 220.83 B addresses calculations for dwellings with additional heating, ventilation, and air conditioning, often abbreviated as HVAC, loads. Carefully performing this calculation is imperative to ensure the existing service is indeed inadequate and to properly size the new service. When upgrading the main service, the utility company will likely need to be involved to upgrade their equipment as well, such as the transformer serving the house. This can involve significant costs and planning. The utility company can provide specific requirements for their connection. When paralleling breakers, it is essential that the breakers used are specifically listed and labeled for parallel operation. Standard breakers are not designed to be paralleled, and doing so can create a safety hazard due to unequal current sharing. The National Electrical Code, often abbreviated as NEC, Article 310.10, H addresses the requirements for paralleled conductors. While this article primarily focuses on conductors, the principle of ensuring equal current sharing applies equally to parallel breakers. The interconnection between the existing and new panels is vital for safety. An interlock device ensures that only one main breaker can be on at a time, preventing the possibility of overloading the service. Alternatively, a main disconnect switch can be used to simultaneously disconnect both panels. This interconnection is critical to maintain a safe and coordinated electrical system. The local electrical inspector will verify that all work complies with the NEC and local codes. Permits are typically required for any electrical work involving service upgrades or new circuits. It is critical to obtain the necessary permits and schedule inspections to ensure the work is performed safely and correctly. Ignoring permits and inspections can lead to fines and require rework. The overcurrent protection devices, like circuit breakers, must have an adequate interrupting rating. The interrupting rating is the maximum short circuit current that the breaker can safely interrupt. The available fault current at the service entrance can be very high, so it is essential to use breakers with an adequate interrupting rating. The electrical service grounding system must be properly installed and maintained. This includes grounding electrodes such as ground rods or ground plates, and the grounding electrode conductor that connects the service equipment to the grounding electrode. A properly installed grounding system helps to protect against electrical shock and damage to equipment. The bonding of all metal parts of the electrical system is also essential. Bonding ensures that all metal parts are at the same electrical potential, reducing the risk of electrical shock. This includes bonding metal conduits, enclosures, and equipment grounding conductors. Surge protection is recommended to protect electronic equipment from voltage surges. Surge protection devices, often abbreviated as SPD, can be installed at the service entrance or at individual panels. These devices help to divert surge current away from sensitive electronic equipment. The location of the new service equipment should be carefully considered. The equipment should be readily accessible for maintenance and inspection, and it should be protected from physical damage. The NEC has specific requirements for the location of service equipment. Labeling of all electrical equipment is essential for safety and troubleshooting. All panels, breakers, and circuits should be clearly labeled to identify their purpose. This helps to prevent confusion and errors when working on the electrical system. When selecting conductors for the new service or parallel setup, it is essential to consider the ampacity of the conductors. The ampacity is the maximum current that a conductor can carry safely without overheating. The NEC Table 310.16 provides ampacity ratings for various types of conductors. Derating factors must be applied to the ampacity ratings if the conductors are installed in conduits with multiple conductors or in high ambient temperatures. Voltage drop is another important consideration when selecting conductors. Voltage drop is the decrease in voltage along the length of a conductor due to its resistance. Excessive voltage drop can cause equipment to malfunction or overheat. The NEC provides guidelines for limiting voltage drop in branch circuits and feeders. The type of wiring method used for the new service or parallel setup must comply with the NEC. Common wiring methods include rigid metal conduit, electrical metallic tubing, often abbreviated as EMT, and non-metallic sheathed cable, often abbreviated as NM cable. Each wiring method has its own set of requirements and limitations. The height of the service entrance conductors above ground must comply with the NEC. This is to ensure that the conductors are not within reach of people or vehicles. The NEC specifies different height requirements depending on the location and voltage of the conductors. The clearances around electrical equipment must comply with the NEC. This is to provide adequate space for working on the equipment safely. The NEC specifies minimum clearances for various types of equipment. The installation of smoke detectors and carbon monoxide detectors is required in most homes. These detectors provide an early warning of fire or carbon monoxide hazards. The NEC requires that smoke detectors be installed in each sleeping area and on each level of the home. Ground fault circuit interrupters, often abbreviated as GFCIs, are required in certain locations to protect against electrical shock. GFCIs detect small ground faults and quickly interrupt the circuit, preventing serious injury. The NEC requires GFCIs in bathrooms, kitchens, and outdoor locations. Arc fault circuit interrupters, often abbreviated as FCIs, are required in certain locations to protect against arc faults. Arc faults are dangerous electrical conditions that can cause fires. FCIs detect arc faults and quickly interrupt the circuit, preventing fires. The NEC requires FCIs in bedrooms and other locations. Ensure that all electrical boxes are properly sized and installed. Electrical boxes provide a safe enclosure for electrical connections. The NEC specifies minimum box sizes based on the number and size of conductors in the box. Use only listed and labeled electrical equipment. Listed and labeled equipment has been tested and certified by a recognized testing laboratory to meet safety standards. Using unlisted or unlabeled equipment can create a safety hazard. Follow the manufacturer's instructions for all electrical equipment. The manufacturer's instructions provide important information about the proper installation and use of the equipment. Failure to follow the instructions can void the warranty and create a safety hazard. Regularly inspect the electrical system for any signs of damage or wear. This includes checking for loose connections, frayed wires, and cracked insulation. Any problems should be repaired immediately by a qualified electrician. Never overload electrical circuits. Overloading a circuit can cause the wires to overheat and create a fire hazard. Use a circuit breaker finder to identify the correct breaker for each circuit. This can be helpful when troubleshooting electrical problems or adding new circuits. Be aware of the location of underground utilities before digging. Contact the local utility companies to locate any underground utilities before digging to avoid damaging them. Use caution when working near power lines. Power lines can be very dangerous. Never touch a power line or anything that is in contact with a power line. Consider the long-term electrical needs of the home. Plan for future electrical loads when designing the electrical system. This can help to avoid the need for future upgrades. Hire a qualified electrical inspector to inspect the electrical work. An electrical inspector can identify any safety hazards or code violations. Correct these issues before energizing the new service. Keep a record of all electrical work that has been performed. This can be helpful for future maintenance and troubleshooting. Educate yourself and your family about electrical safety. This can help to prevent accidents and injuries. Avoid extension cords and power strips. Wherever possible, plug appliances directly into wall outlets. If extension cords or power strips are necessary, use heavy-duty cords that are rated for the intended use. Never run extension cords under rugs or furniture. This can cause the cords to overheat and create a fire hazard. Use tamper-resistant receptacles in areas where children are present. These receptacles have a built-in safety mechanism that prevents children from inserting objects into the slots. Install ground fault circuit interrupter, often abbreviated as GFCI, protection for all outdoor outlets. This will help to protect against electrical shock. Keep electrical equipment dry. Water can conduct electricity and create a shock hazard. Use caution when working with electricity near water. Be aware of the signs of electrical overload. These signs include flickering lights, warm outlets, and burning smells. If you notice any of these signs, turn off the circuit breaker and call a qualified electrician. Never attempt to repair electrical equipment unless you are qualified to do so. Electrical work can be dangerous. If you are not qualified, call a qualified electrician. If you have any doubt about electrical safety, consult a qualified electrician. Electricity is a powerful force. It is important to respect it and to follow all safety precautions. Consider energy efficiency when upgrading the electrical service. Use energy-efficient lighting and appliances to reduce energy consumption. This can save money on utility bills and reduce the environmental impact. Obtain multiple bids from electrical contractors before hiring one. This will help to ensure that you are getting a fair price for the work. Check the references of any electrical contractor before hiring them. This will help to ensure that they are qualified and reliable. Get a written contract from the electrical contractor before work begins. The contract should specify the scope of work, the price, and the payment schedule. Make sure that the electrical contractor is licensed and insured. This will protect you in case of any accidents or damages. Communicate clearly with the electrical contractor throughout the project. This will help to ensure that the work is done to your satisfaction. Keep a copy of all documents related to the electrical work, including permits, inspections, and contracts. This will be helpful for future reference. Be patient with the electrical contractor. Electrical work can be complex and time-consuming. Allow sufficient time for the work to be completed properly. Thank the electrical contractor for their hard work. A little appreciation can go a long way. Review the electrical work carefully after it is completed. Make sure that everything is working properly and that there are no safety hazards. If you have any concerns, contact the electrical contractor immediately. If you are not satisfied with the electrical work, contact the local building department. They can help to resolve any disputes. Remember that electrical safety is everyone's responsibility. Take the necessary precautions to protect yourself and your family from electrical hazards.